Hello, welcome to Unit 1, Lesson 11, Comparing and Contrasting Data Distributions. So let's take a look at the first activity. In this activity, it says to evaluate the mean of each data set mentally. See if you can do it without necessarily adding and then dividing. You might have to, but see if you can do it without doing that. So pause the video and see if you can figure out what each of these means are. All right, let's take a look at the first one. Now, if you recall, in the last lesson, we talked about how data that is symmetrical, the mean and median are the same number. So if we think about this first set of data, 27, 30, and 33, and we can imagine if we were to create a dot plot, what that would look like. So in our dot plot, we would have 30 in the middle, and then 33 would be 3 to the right, and then 27 would be 3 to the left. Since this is symmetrical data, right, we can see here they both have 2 spaces in between them. We know that the mean and median are going to be equal to each other. So in this case, the median is 30, so that means that the mean is also 30. Now, we can also apply this strategy to the second question. Here, 81 is in the middle, and the points on either side of 81 are equal distance from 81. So, for example, 71 is 10 away from 81, and 91 is 10 away. 61 is 20 away, and 101 is 20 away. So again, this data is symmetric. So because it's symmetric, we know that the mean and median are the same. So that means the mean is going to be 81. Now for the next one, this definitely is not symmetric data. We can see that we have a little bit of an outlier here. This 0 is kind of throwing things off. So this would be more skewed data. So it is skewed left because most of the data falls on the right side. So what's on the left side is skewed from the rest of the data. And because it's skewed, we know that the mean is going to be different from the median. And in this case, because our outlier is smaller than what the mean would have been, we know that the outlier is going to pull that mean down. So I know my mean is going to be smaller than 100. To figure out what exactly it is, to be honest, the best strategy would just be to add and divide. But this is pretty easy addition and division. If we have 4 100ths, that's 400. We have 5 numbers. 400 divided by 5 is 80. So it's easy. And then last but not least, we have our 0, 5, 6, 7, 12. This is symmetric, right? 5 is 2 away, 7 is 2 away, 12 is 6 away, and 0 is 6 away. So because it's symmetric, we know our mean and median are the same. So my mean is going to be 6. All right, let's take a look at the next activity. This activity is a matching activity. You can find the link to the activity in Canvas on the homepage. So go on to Canvas and access the Desmos link so that you can do the matching activity. Once you have sorted all of your matches, take a screenshot and add it to your notes. Because any mistakes that you make, I do want you to correct them. All right, so now that you've made the matches, let's go over those answers first. So, the data display A goes with the description for I. Data display B goes with the description for L. C goes with N. D goes with M. E goes with J. F goes with K. And G goes with H. Now that you've made the matches, go ahead and answer question 2. So it says, after matching, determine if the mean or median is more appropriate for describing the center of the data based on the distribution shape. Make sure that you have a good reasoning. You don't necessarily have to discuss with a partner. If it's not given and you can calculate, go ahead and calculate or possibly estimate what the appropriate measure of center is. And then make sure that you have some reasoning to go along with it. So go ahead, pause the video and work on that. So for these data displays, anything that presented as symmetric, you're going to want to choose the mean as the best measure of center. So the ones that are mainly symmetric is data display A, data display B, C, and then also F. So those four, you're going to want to use the mean for. The other ones are skewed, and whenever you have a skewed data display, you're going to want to use the median. So that would be D, E, and G. So for A, it already gives you the mean, so you don't have to do anything with that. For B, it gives you the mean as well, so we know that's -14. For C, it also gives you the mean, so that's also -14. And for F, it gives you the median. So this is the only one that it doesn't give you the mean for. So taking a look at F, it does give us the median. It says the median is 14 with that information. And what we know about symmetric data is that the mean and median are the same. So if the median is 14, that tells us that the mean is, or -14, sorry. That tells us that the median, or the mean, is also -14, not -4, -14. All right, let's look at D. For data display D, it does give us a median of 11. For data display E, it gives us the median as well, so that's 14.5. And finally, G does not give us the median. It does give us the IQR, but that doesn't really help us find what the median is. So you can do that by just kind of crossing out the points until you get to the very middle. But in this case, the median is 20. So as we have mentioned in previous lessons, whenever we have symmetric data, the mean is definitely going to be the best measure of center. And you may be asking yourself, well, does it really matter if they're both the same? And the reason why it does make a difference is when it gets to our measures of variability. So when it comes to measures of variability, we've talked about two of them so far. We have talked about MAD, mean absolute deviation, and we have also talked about IQR, interquartile range. They go hand in hand with each of the measures of center. So MAD goes hand in hand with mean, IQR goes hand in hand with median. And so the reason why we choose mean when we have symmetric data is because MAD is a better, or I should say a more reliable measure of variability than IQR is. So if we have a choice between mean and median because they're exactly the same, it makes more sense to choose the mean because then we can also use the mean absolute deviation, the better measure of variability. But sometimes using the mean is not possible, so therefore the mean absolute deviation is also not going to be a good measure. So that means we then have to rely on the interquartile range, or the IQR, when we are dealing with more of a calculation with medians. So let's move on to the next activity. All right. So in this activity, it says each box plot summarizes the number of miles driven for 30 days in each month. The box plots represent in order the months of August, September, October, November, and December. The 5 box plots have the same median. Explain why the median is more appropriate for describing the center of data set than the mean for these distributions. So the box plots are listed under number 2. And then once you've answered that, it wants you to arrange the box plots in order from least variability to greatest variability. Once you finish with the box plots, you need to move on to the dot plots. This one says that these 5 dot plots all have the same mean. You need to explain why it's more appropriate for describing the center of data than the median is. And then, again, arrange the dot plots in order from least variability to greater variability. So go ahead, pause the video, and work on those questions. All right, let's take a look at question 1. So looking at these 5 box plots, we can see that the data is not symmetric. And as we have mentioned before, when the data is not symmetric, it makes more sense to use the median rather than the mean. So the data is not symmetric. Now, when we're calculating the box's variability, remember with median, the measurement of variability that we use is the interquartile range. So for each of these, we're going to want to approximate for, we might be able to find the exact for most of them, probably for all of them. Yeah, okay. So we're going to go ahead and calculate the IQR. Now, if you use range, that's not necessarily a bad thing. Like you could use range as determining the variability, but in general, idea when it comes to on the overall variability of a data, we really want to focus on that middle 50% because what that does is it kind of takes out any possible outliers that may be existing. So let's go ahead and calculate the IQR for each of these. So for the first one, we have 60 minus 20, which is 40. For the second one, we have 70 minus 10, which is 60. For the next one, it looks like it's about 85 minus 15, which is 70. And then we have 70 minus 30, which is 40. And then the last one, we have 50 minus 30, which is 20. So if we want to arrange these in order from, least variability to greater variability. The one with the least amount of variability is E. Next, we can see that D and A both have the same IQR. So when determining which one has more variability or less variability, you take it a step further and now you look at the range. So the range of D is much bigger than the range for A, so that means I'm going to say A would come next and then D. After D would be B. And then rounding it up would be C. So again, we're using IQR for the most part, except for that one where we had 2 IQRs of the same. We took it a step further and just used the overall range to determine which had a greater variability. All right, let's look at questions 3 and 4. So for 3, it says, why should we use mean for this one instead of the median? And when we look at all of the dot plots, we can see that they are symmetric. Since they are symmetric, we've talked about how the mean and median are basically the same. So we're going to want to use the mean in this case because that allows us to use the mean absolute deviation, which is a better form of variability. So these are symmetric. It helps if these are symmetric. And the other thing I want to point out is that they're symmetric and plus there are no visible outliers. or no obvious outliers. So again, we're going to arrange these from least variability to greatest variability. So the least variability, that's pretty easy. Data display E has no variability at all because everything falls on E. So E would definitely go first. For determining the others, we're going to want to look a little bit closer at where most of the data, where the middle of the data is, and compare it to where most of the data ends up following. So it told us that the mean was the same for all of them. So that means we all have a mean of 10. So that's our measure of center. And the farther the numbers are away from that measure of center, the more variability there is. So if we look, we can see that data display C has actually most of the data that's pretty far from that middle measurement, from that measure of center. So that tells us that one is going to have the most amount of variability. So I know I'm going to be listing that one last. Looking at data displays A, B, and D, though, B actually has most of its data in the middle, right? That 10 is significantly longer than the other data points. And then if you even went out one further, right, 9 and 11, which are only one away from 10, now contain the next amount of points. So the variability here is not very much. It's on the smaller side. So our next display, that would be the letter B. And then we're comparing A to D. Now, A is a bell-shaped curve, right? We can see that it, again, has more points in the center. And if you went out one further, you would see that most of the data points fall between 9 and 11. Now, the reason why this has more variability, though, than data display B is because that the 10 is not much bigger than 9 or 11. And data display B, the 10 was significantly bigger. So that means there were more points in that very middle, that measure of center. 10 doesn't have as many points, although it still has the most amount of points. It's not significantly more than the other data points. So A would be next. D is uniform. So every data point has the same amount. And even still, this is going to have more variability than A or B, but not as much variability as C. So D would be next. And then that leaves us with C. So the key thing I want to point out here is that when we are calculating measure variability connected with the mean, we are using the mean absolute deviation. And remember, mean absolute deviation is just how far does the data point deviate from the mean, and then you take the mean of those numbers. So that's what we're looking at when we're looking at a dot plot. How many points deviate from the mean, which is 10, and the more that deviate from the mean, the bigger that measure of variability is going to be. We really want a small measure of variability, so we want everything to kind of stay centered around the mean. All right, so key things to remember here when we're talking about measure of variability. So far, the two measurements that we have been working with are IQR and MAD. IQR goes hand in hand with the median. MAD goes hand in hand with mean. And measure of variability is just telling us how much the data varies from the measure of center. So how much the data varies from the measure of center. So when you're calculating IQR and MAD, the bigger the number it is, the more the data varies. And when researchers are conducting experiments and they're looking at the statistics, they really want the variability to be on the smaller side, because that smaller measure of variability just means that your results were more reliable. So, for example, I think of medical companies and pharmaceuticals who are trying to come up with a drug that helps certain symptoms. When they do trials, they're going to collect all these statistics and they're going to calculate mean absolute deviation, or IQR. And then we'll even get into standard deviation in future lessons. And they know if that their variation is on the smaller side, that their results are more reliable, that they can say that, yes, this drug does do what we want it to do. So this part of statistics is really, really important for a lot of researchers out there. Now, when it comes to calculating the mean absolute deviation, IQR, obviously IQR, a whole lot easier to calculate, but there are ways to calculate the mean absolute deviation to make it meaningful. So just keep in mind that when you are calculating measures of variability, use IQR for the median and use mean absolute deviation for mean. So that's it for this lesson. Don't forget to submit this for points and do your cool down. Thanks for watching.